Okay, well, blood types basically come down to these proteins that are on the surface of your cells. There are three possible proteins. In this case, these proteins are called antigens. We can get even more specific and more useless with the name by naming them exactly what they are. I think they like agglutinins and agglutinogens if we want to get into it, but antigens is perfectly fine. That can exist, on the surface of a red blood cell. Okay. Anybody know what those antigens are? Yeah, there we go. The first one is the A antigen, which means you can probably guess the second one. The B antigen. Now the next one, that's what I thought you might say, but it's no. Next one will be really tough to come up with, okay? The next one is the RH antigen. All right? Here's how we break it down. If I have the A antigen, my type is A. Very simple. Therefore, blah, 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 blah. B antigen, my type is B. Have both A and B antigens. Then what am I? AB. I have neither A or B. And my type is O. When you think of O, I want you to think of it like 0. You have 0 of these AB antigens. Okay? So these can exist, these ABO types, AB antigens, moreover, can exist in any combination. So that should beg the question, what?
How many combinations are there?
We established that right up here. But what have I not addressed yet?
RH?
Yeah. With any combination. If someone has the RH factor, their type is positive. Okay? If someone lacks the RH factor, their type is negative. So, basically, if I have the B antigen and the RH antigen, what is my type? B positive. And that is my type, actually. I try to be positive. Yeah. All right. So the question, why does this matter? Somebody asked me that question from a survival standpoint. Mr. Helly, is there one that's more advantageous as far as survival as having O or A? Does it give any other physiological function? Is there some sort of major advantage to being one type or the other? Will eventually one type take over for evolution and that type of thing? No, there is really no physiological significance to having one type or the other except where transfusions are concerned, which is transfusions have really only existed, successfully, for the last 100 years or so. They've attempted them all the way far as back as the 1600s. Some of them went great. Some of them did not. Okay? But they didn't know until the early 1900s why they went well and sometimes they didn't. Here is why this matters for us as far as health science, is because antigens, and this is a big idea right here, antigens, which are what again? What are antigens? They're proteins, that's right. Antigens are attacked by antibodies. Guess what antibodies are? They're proteins. Are we seeing a theme here? All right. Antigens are attacked by antibodies. And antibodies trigger something called agglutination. Agglutination is a fancy word for clumping. It causes these cells to be clumped up together. Oh, I'm sorry. Yeah, you're right on the line. Antibodies trigger agglutination, or some sort of clumping, where these all basically clump together. And you can see why that would be bad. Your blood to be functional needs to be able to flow through your bloodstream without any issues. But yeah, it's difficult for it to do that if it starts clumping. Now, I want to be very specific here. This is not clotting. This is clumping together of red blood cells. Clotting has to do with which of your cells? Platelets. The platelets, right. So I need you to divide that out in your mind here. So
when you have a heart attack, is that from clumping or clotting?
That is from clotting. That's from clotting. Like I said, it's only really when you get a transfusion of the wrong type that you would see this type of agglutination, which it doesn't normally occur. Okay? So if someone receives the wrong blood type, incompatible. Okay, doesn't necessarily mean if they don't get the exact same type, then that doesn't necessarily mean that it's going to happen. Their blood will clump. Causing death. Okay? There may be measures that they can take if they find immediately when they begin a transfusion, if there's some sort of reaction, they may be able to take countermeasures and whatnot. I'm not exactly sure what those are, but yeah, put the whole thing in. That clumping blood is death. Okay. Therefore, in fact, I'm going to throw a therefore in there. Therefore, we can use these antibodies to test blood type. And here's how it works. We take just a regular slide, okay? And we're going to use transparency film because the days of the overhead projector are over for the most part in the high school here. And so we have like cases of transparency film that's not doing anything, then it won't. So we just cut them up because I never feel comfortable about using a like glass slide again once it's had human blood on it and stuff. It's even if you bleach it, clean it, I still don't feel good about it. So on this slide, we're going to divide it with a Sharpie, or a little plastic piece of transparency film. We're going to divide it into 3 sections: A, B, and RH. Okay. And we're going to place a drop of anti-sera on it. Okay. Anti-sera is basically a liquid that includes these antibodies. Okay. All right. So this is a drop of anti-A. This is a drop of anti-B. This one right here will be a drop of anti-RH. Sometimes they will call that D. That's not really catching on though. The RH factor is pretty universal worldwide, but sometimes in these solutions they'll call this the anti-D. So if you see that, know that that's what that is. Okay, I don't think it's going to catch on. What's your blood type? AD. Like after Jesus, or so. It doesn't really work that way. And then what we're going to do is you're going to poke a hole in your finger right about there. I like that spot. A bunch of them recently. You're going to place a little droplet of blood here, here, and here, right above in those little sections here. I always start with the RH because this one takes the most blood to try to react with it. And you're going to take a toothpick and mix those together like that. And you will look for what? Clumps. And the cool thing about this is that you don't even need a microscope. You will see the clumps. Like it looks like it's this one here is blue. When it mixes together, it makes sort of like a dark purpley color with your blood. And then all of a sudden, if you have the A type, it will be perfectly blue again with these red clumps in it. It separates all of it out. It's really pretty cool. This one's harder to see, but with these two right here, you really get a quick picture of that. And so, okay. So now, from there, this is another big idea that I don't want you to confuse. I want you to put a big star next to this one or some sort of thing, or draw a toaster, whatever it is that you would need to draw in your notes to recognize that this is a big idea, okay? We have, and it can be confusing if you don't read it slowly, we have antibodies for all types of antigens that we don't have. Okay? That's confusing. I'll read it again and then I'll give you an example. We have antibodies for all types of antigens that we don't have. Okay? So, example, B positive type blood. Okay? So, start with antigens, antibodies. Okay. Antigens.
Is that an equal sign?
Oh, that's like a makeshift arrow. Sorry. What kind of antigens will this individual have? Or will I have, because this is my type?
You'll have the B plus.
Okay, I have the
You'll have the
B
D and the RH.
antigen and the RH antigen. What kind of antibody will exist in my bloodstream?
All the others.
There's only one. It would be the anti-A. Okay, for the antibodies, we're going to use anti. So I have B antigen, RH antigen. I will not have the anti-B or the anti-RH, or my blood would agglutinate itself and I wouldn't have survived this long. Okay, but I do have the anti-A in my bloodstream, which means if A got introduced into my bloodstream, it would certainly agglutinate it. Okay. So if I were to do, let's do one more example. O-type blood. Let's go with O negative. Okay? Antigens. What antigens would that have? None. There would be none. Antibodies, however, it would have what? Anti-A, anti-B. What else? B and anti-RH. Okay?
So they can only receive O negative type blood?
That's exactly right. Okay? And therefore, let's go to the other end of the spectrum. AB positive type blood, antigens, antibodies. Okay, antigens would be what? Would be the A antigen, B antigen, and RH antigen. Antibodies would be none. Okay, therefore, and this is the last thing we'll have in our notes today, therefore, O negative is the universal donor. Because O negative has no what? Antigens. There is nothing that would cause, nothing on these cells that would cause anybody else's cells to react with it. One of my students last hour was like, that would explain why the Red Cross keeps calling me. I said, why? He goes, I just got my card in. He showed me. Guess what type he is? O negative. If someone's bleeding out in the hospital in the emergency room, no matter who it is or what's going on, they know for a fact they can give them a bag of O negative and it won't react adversely with their blood, so they keep that in quick supply. Yes?
Once somebody receives O negative blood, which means that they have antibodies from that blood, can they not receive from any other types?
Okay, this is where it gets a little bit confusing, and that's true. And that's very good insight, because you think, okay, now that they have these in their system, the difference is these two things. You're receiving a pint of blood or 2 pints or so into, and I hate to change between English and metric, but or standard and metric, into about 6 liters of blood, okay? It takes a fair number of these to actually trigger agglutination. So this will not cause agglutination by itself. That's a great question. So they can still receive, other types of blood, and they don't have to worry about that kind of thing. You have to be concerned with whether or not you have these in your system, not so much in what's being introduced into your body. Very good question. Okay.
Is there like the most common blood type?
There is, but I don't want to spoil that yet. Yeah, I know.
Is there a least common too?
There is.
Or is it O negative?
I don't want to give away the surprise because we're going to compare our stats to the national stats after we get everyone's collected all day. When are we drawing and typing blood, gang?
Good question.
How are we doing today?
That's going to be Monday. Okay.
This coming Monday?
Yes.
So does it ever change the blood over to your type?
It does not, because you are still going to be creating cells of your type. Now, temporarily, you will have the cells of that type going through your bloodstream, but they only last. They'll die off and be killed off because your body's constantly removing old blood cells from circulation and putting new ones in. So as that number of the different type will start to diminish. Okay, and this is the last thought. Second to last thought. AB positive is the universal recipient. Because AB positive has no what? Antibodies. Last thought here, okay, is that positives can receive what? Positive or negative. Negative can only receive negative. Okay. All right. Go ahead. What's the question?
Why is that?
For the same reason, these guys that are negative will have the anti-RH, and so it would cause the blood to agglutinate. Okay. Positives will not, and so they can receive negatives.